Hi, everybody. This is Dan Reeser from the Web3 Foundation, and I'm joined here with Adam Dossa from Polymath. He's their head of blockchain. Um, Thanks for joining again. Hopefully some of you have seen some of our previous Web3 Builders crowdcasts, but we really wanted to get this started to talk broadly about the Web 3.0 ecosystem, teams that are building on Substrate, building with Polkadot, and building in the Kusama ecosystem. So Adam is here to talk a lot about Polymesh, the new project that Polymath is working on in relation to security tokens and using the Substrate toolkit to help them build this project. So Adam will go over that today, and I'll kick it over to Adam to kind of introduce himself and get started. So thanks, everyone.
Thanks very much, Dan. Great to be here. Thank you very much for having us on the crowdcast today. So as Dan says, I'm Adam Dossa. I'm the head of blockchain at Polymath. So I want to kind of start, so I'm going to talk a lot about Polymath and Polymesh today. And I want to start by sharing our mission statement to Polymath, which is to unlock global access to wealth creation through a digital economy. So kind of in the furtherance of this aim, by way of background, we have a layer 2 protocol, which has been live for a couple of years on Ethereum. As of last year, we started building a new blockchain based on the parity substrate framework called Polymesh, which is what I'm going to be focusing on today. So we recently, I think a couple of weeks ago, we released a white paper outlining the vision for Polymesh and starting to kind of flesh out many of its details. We are going to be releasing additional papers and articles and documentation and that sort of thing as we approach the testnet and mainnet rollout. Those will kind of dig into more detail into different areas, things like governance and tokenomics and confidentiality and identity. So those articles and kind of papers will be coming out over the next few weeks and months. So my aim today is really to kind of give a brief overview of a few different things. I want to talk a little bit about why we chose Substrate for Polymesh, so why we're using the parity substrate framework, and what some of the kind of decisions around that were. I'm going to talk a little bit about our architecture and design decisions that we're making for Polymesh, and I'm going to briefly touch on we have kind of 4 core design principles in Polymesh, which are identity, confidentiality, governance, and compliance. So I'm going to touch on each of those briefly. And then I've got a couple of slides at the end, which sort of do a deeper dive into one specific area, which is identity, which is, identity is kind of absolutely the core of Polymesh. So let me flip to the next slide. So what does our journey to Substrate look like? So, Polymath came into being in 2017, and we had this kind of clear vision to bring regulated securities to public blockchains. The reason to do that were to kind of leverage the transparency, the innovation, the interoperability, and accessibility that DLTs provide. And back then, so this is like 2017, early 2018, building on Ethereum made a ton of sense. Ethereum it was relatively mature. There was some tooling, there was community, there was sort of best practice around smart contract development, and building on Ethereum allowed us to prove out our concept, gain traction and distribution, and probably most importantly, learn a whole bunch of hard lessons. So the protocol on Ethereum has been live for a couple of years. It's had great traction and adoption. We've had over 100 companies issue security tokens through it, but there've been these kind of interesting lessons that we've learned, and that's really what sort of fed into our approach with Polymesh, with the Polymesh blockchain. So there's a whole bunch of lessons we learned. I think some of the more interesting ones are around the importance of standardization. So standardization and standards are something the financial industry is kind of intimately familiar with. They've probably existed as long as the kind of modern financial system has existed. They cover all sorts of things, from how different participants communicate to how you represent different types of assets and so on. And in the Ethereum space, Polymath, with the kind of help of the community and other stakeholders, put together ERC 1400, which is a kind of collection of interoperable standards for security tokens that cover different ways or different aspects of security tokens, from sort of lifecycle management to asset modeling and so on. So a lot of those kind of lessons and I guess ideas that went to ERC 1400, although ERC 1400 is an Ethereum kind of focused standard, the majority of those ideas and approaches carry over very nicely into Substrate. I'll talk a little bit more about that later. The other really important lesson we learned is that Polymath wants to be a global platform, right? We want to be able to cover a whole range of different regulated assets and a whole range of different jurisdictions. And what that means is that there's a lot of different ways that assets and jurisdictions can be combined. A lot of different ways that you have to manage compliance with different types of assets, crossing or covering jurisdictions. And the lesson we learned with on Ethereum is that you really need to have a very modular, flexible, and extensible design. So you want your users of the network to be able to take your kind of financial primitives, all of this logic at the base layer, but to be able to send it in a flexible way so that you don't have to kind of provide all of the functionality you need for every possible different type of compliance rule out of the box, but you kind of give people the tools to extend the financial primitives provided by Polymesh as needed. So that's another important lesson we learned. And I'll talk a bit about how we plan on achieving that in Polymesh using smart extensions later. The other kind of key insight is that regulated securities have a lot of different stakeholders. So I'll list out some of them. This is not not an exhaustive list, but you have issuers, you have investors, you have regulators, you have kind of KYC and AML providers, you have custodians, exchanges, legal firms, marketing firms, and standardization bodies, and many, many more. And one of the things that Polymath has done very successfully over the last couple of years is work kind of collaboratively with a whole range of different stakeholders. So that's reflected in things like ERC 1400 and a whole bunch of other areas and standardization bodies that we sit on and contribute to. And there's this kind of, although we obviously have competitors in the space, there's a whole bunch of companies working in this space, the overriding kind of motivation or aim is really to grow the size of the security token market. So as much as companies obviously want to increase their share of the pie, right now, really everyone's focus, as it should be, is on growing the size of that pie and kind of growing the number, the assets under management which are represented on public blockchains. So that's important. It takes a lot of stakeholders to kind of bring these things to market, and bringing all these stakeholders along with you is very important to Polymath and kind of central to our approach. I guess more kind of technically, whilst Ethereum has been very useful to kind of gain some traction and learn these lessons, Ethereum is a general purpose blockchain. It was designed to be general purpose. It's not tailored or optimized to any specific use case, whether that's security tokens or prediction markets or gambling and so on. It's not optimized for any specific purpose. And as a result, lots of the kind of trade-offs that Ethereum makes or design decisions that Ethereum makes are really suboptimal for our specific use case, which is regulated assets, capital markets, and so on. So some kind of very quick examples, things like the kind of gas fee and pricing approach in Ethereum, which allows front running, is an issue that's often cited as being problematic when it comes to securities. Privacy being a sort of layer 2 construct is somewhat problematic, or adds a lot of complexity around privacy, and privacy and kind of confidentiality, as I say, is one of the kind of key 4 design principles of Polymesh. There are some sort of technical issues around the way finality is provided on Ethereum. So in Ethereum, which is currently anyway a proof of work network, finality is probabilistic. So we've seen block reorganizations, not so much in Ethereum, but certainly in things like Ethereum Classic and some other blockchains. We've seen pretty large block reorgs, which are, I guess, fairly obviously problematic if you're dealing with securities and asset transfers in general. Seeing having a block reorganize itself and have transactions that were could have maybe been considered finalized become unfinalized is problematic. Governance, so I have a lot of respect for Ethereum. Ethereum tries very hard to kind of cleave to this decentralized governance approach. We've seen that in action with things like the ProgPow fork discussion recently. But it is this sort of decentralized governance, whilst it might make sense for Ethereum, is quite problematic for larger institutions and the security space where identity and compliance is so important. One of the great things about Substrate is that because the kind of state transition function of the blockchain is actually held under consensus itself, it makes the forking process, or rather, I should say, if you want to upgrade the network, it makes that process a lot simpler, a lot smoother, and gives a lot more clarity to institutions or individuals or organizations that are using the blockchain. And then lastly, Ethereum is obviously permissionless. That means that miners are effectively anonymous. And this is something that large institutions often raise, is that if you're a large bank and you make a transaction, it's possible that your transaction is actually mined and included in the block by a miner that's in, say, North Korea, which means that not only has managed your transaction, you would have also paid them a fee as a transaction fee to potentially a miner that may not be maybe in a country where you're not meant to make payments to. For large institutions which have this kind of really high bar around compliance, that can be very problematic. So there's a whole bunch of lessons learned, a whole bunch of kind of reasons that we saw this great opportunity to build an optimized blockchain, which is purposed specifically around security tokens and regulated assets and compliance. And Substrate, Substrate kind of, I guess, is great because it gives you a whole bunch of functionality out of the box. So things like your your consensus algorithm, your networking protocols, all of these kind of basic palettes that help you manage native currencies and other things all come out of the box. And you can also modify those. So, for example, we've modified lots of that functionality to reflect the fact that Polymesh is permissioned. And you can also add in your own palettes, your own modules, which we've done to add modules for things like identity and regulated assets and so on. So it's this kind of great combination of providing a whole bunch of functionality out of the box, whilst giving developers the ability to modify that functionality and add in their own logic at layer one. So I'm going to talk a little bit about the architecture we followed. Let me just I'll talk a little bit about the architecture. I have seen there's one question asking about a test net, so I will come back and address that before the end. So on the architecture side, I'm going to split it into three layers for this presentation. The first is kind of like around, I guess, security of the network, or the sort of base layer of the network, or the enabling economy. So the base layer of Polymesh needs to match the needs and requirements of regulated markets, capital market institutions, and so on. And this is critical if we want to achieve widespread adoption. So what does that mean in practice? So we have a few kind of key bits to that. The first is that all network participants need to go through a basic customer due diligence process, which is this federated CDD process on the slide. So this ensures that network participants are privately linked to real life legal entities or identities, that they're not in sanctioned countries and so on. And it helps to provide a certain amount of provenance around the Poly native token on Polymesh. All ownership of Poly and transfers of Poly and use of Poly and so on can be linked back to an identity that's gone through this basic customer due diligence process. So it helps provide some provenance around the token and the blockchain. And actually, there's a few other advantages. So it helps give you a certain levels of civil protection and so on, which can be useful in other areas, which I'll touch on later. So how is this process managed? So it kind of brings us to the next topic, which is on-chain governance. So on-chain governance is pretty interesting. It's an area that we've seen. There's been lots of innovation, lots of exploration and experimentation in on-chain governance. It's not something really embraced by Ethereum, but with chains like Polkadot and Kusama and Tezos, are all showing, are all taking pretty interesting novel approaches towards moving lots of the chain governance on chain. And Polymesh does this as well. So we have on-chain governance, which kind of provides, it kind of combines token holder, so Poly token holder input and voting and so on, with these kind of second layer governance committees, so a range of different committees that help to manage governance in different areas like network upgrades and tokenomics and so on. So we have this sort of two-layer process involving both token holders and these committees. And it's this governance which handles things like, decides what KYC providers are eligible or trusted to provide this CDD claim. It handles things like tokenomics parameters, so our reward percentages and how tokenomics are managed on the chain, and also manage network upgrades. So we want to release a new version of the blockchain and so on, helps to manage that network upgrade process. So we have this kind of we have this on-chain governance, which helps to manage all these different aspects of the chain. It's all transparent, and so that there's a place for both token holders and committee members to get involved. The last thing to talk about, so Polymesh rather, is a permissioned blockchain. So what that means is that it's a permissioned public blockchain. So that the state of the blockchain is public. So anyone can run a light node or connect to a light node and check the state, the current state of the blockchain, see that state evolving, check what the kind of state transition function is, make sure that all the participants are following the rules and so on. But the entities which validate blocks, so collect together transactions into blocks and then check the correctness of those blocks, are permissioned. And this is in contrast to blockchains like Ethereum and Polkadot, Sama, where validators are not permissioned. So why do we take this approach? I mean, it helps to solve a lot of the problems I mentioned earlier. So, it means that if you're making payments on the network or you're interacting with the network, you know that your transactions are not being handled by an organization which might be in a sanctioned country and that type of thing. So it helps kind of solve some of those problems. And it also helps to increase the security of the network. So rather than just relying on kind of crypto economic guarantees around things like proof of stake and block reward incentives and slashing, you also have security. You can also kind of bolster that security through the idea that the validators on the network are publicly verifiable organizations. They may be regulated. They have a public reputation. So you have these kind of additional, let's say, assurances or security of the network that derives from that. So those are some of the reasons we introduce this kind of permission layer over validators in Polymesh. A couple of other things to talk about. I'll talk about them now. They don't actually appear on the slide. So I mentioned confidentiality as being one of the kind of key planks or key design principles of Polymesh. Again, confidentiality for securities is a pretty interesting area. There are these kind of trade-offs between investor privacy, which for equity or security positions is really critical. But there's a trade-off between that, regulatory oversight, so the fact that regulators may want to have certain may need to do due diligence or understand transactions on the network, and the fact that issuers of assets will almost certainly have various reporting requirements. So there has to be some types of data that's shared between investors and issuers so that issuers can fulfill their own reporting requirements, but you want that data to be private and not public to everyone in the world. So it's a really interesting space. I think it's very different to the kind of privacy you see with currency coins or confidentiality you see with currency coins, which is probably less. There's fewer trade-offs to consider or fewer stakeholders to consider, maybe. So my belief and the kind of approach we're taking with Polymesh is that the market will embrace both non-confidential assets. So these are assets which are sort of have pseudo-anonymity, similar to ERC20 tokens and Ethereum and so on, as well as confidential assets, where confidentiality brings in a certain amount of kind of technical complexity and UX complexity, but obviously brings a whole bunch of advantages to investors and issuers and so on. So my belief at the moment is that both of those types of assets will have a use cases, let's say. We're aiming to release. We have a paper around confidential, or we have some more details around confidentiality that we're aiming to release in the next few weeks, which will help kind of flesh out our approach there. Okay, let me flip to the next slide. So next set of things in our architecture, these so-called runtime modules or palettes, as they're known in Substrate. So these are pretty straightforward. One of the great things about Substrate is it lets you build in logic at layer 1, right? So in your normal kind of general purpose blockchain, everything has to be at layer 2. But with Substrate and Polymesh, we can add these kind of key financial primitives at layer one. So things like identity, key management, regulated assets, compliance, settlement, and so on. And this is not an exhaustive list. Can all be built as runtime modules. And our code is open source. And if these are, if you're interested in any of these areas, you can go and take a look at our code and take a look at how we're approaching these. So we have these kind of runtime modules as layer one constructs. And why is that important? I think, first of all, it gives a very standardized approach towards regulated assets. So rather than having everyone who's issuing an asset get their own, kind of come up with their own approach to how they're going to manage that asset and how they're going to represent that asset, you have this kind of standardization locked in at layer one. And that makes it a lot easier for third parties and stakeholders to integrate with Polymesh. There's this kind of standardized approach. People like exchanges, custodians, and transfer agents, it becomes a lot faster and cheaper for them to integrate. And on that side, I guess one of the other nice things about Substrate, from that many industry participants are already familiar with integrating with Substrate chains. So they may have already had taken a look at Kusama or Edgeware or Polkadot. So they already have a lot of the kind of knowledge and technology they need to integrate with Substrate-based chains, which helps to kind of bootstrap and accelerate integration with Polymesh. I see a few questions coming in. Okay, I will definitely come back and address all of those. Let me just flip to the next slide. So the last thing on the architecture side I want to talk about are smart extensions. So one of the lessons I said we learned from Ethereum is that our protocol or the blockchain has to have this kind of flexibility or this modularity and extensibility if it wants to be, if we want to fulfill our aim to be a kind of truly global blockchain that can cover any asset or jurisdiction combination. So what that means in terms of Polymesh is that we have these runtime modules that they represent things like assets and so on, and identity, but we want those runtime modules to be able to be extended flexibly in a somewhat controlled manner. So smart extensions are how we approach this. So a smart extension is really just a smart contract. It's written in a particular DSL, and it has to conform to a certain interface and specification. And that smart extension can then be attached to a specific asset or potentially some of the other runtime modules and modify the behavior of that module. So a good example would be, say, for compliance or transfer management, as it's described here. So suppose you have some new type of transfer management rule. So perhaps you have to limit the maximum number of investors in your asset. One way to do this would be you create a smart extension, which is, let's say, just a smart contract. That smart extension encodes the logic you want. So maybe the smart extension encodes the fact that you're only allowed to have at most 10 investors in your asset. And if somebody tries to transfer assets that would break that rule, the transfer should fail. And you then attach that, you then deploy that smart contract to the network. You then attach that smart extension directly to your asset, to your Acme asset, let's say, that needs to have that compliance rule. So because smart contracts are Turing complete, you can encode any type of, say, compliance logic or transfer restriction logic you want in that smart extension. It allows you to augment or extend the compliance logic of your asset really in any way that you see fit. So it's a great way to kind of bring this extensibility. I think one of the other things it highlights is that I think it's one of the interesting ways that something like Substrate or this kind of new breed of blockchains differentiates themselves from previous blockchains. This idea that you can have this kind of base layer logic represented by runtime modules alongside this dynamically deployed sort of smart contract logic, and you have these sort of rich interactions between smart contracts and runtime modules. Is something which is pretty novel, and it's not something you can do in any other blockchain, to my knowledge. I guess one other interesting thing to mention is that when we first started looking at Substrate last year, this ability for smart contracts to richly interact with runtime modules was missing. So smart contracts kind of lived off in their own sort of playground, and then runtime modules lived in their own playground. There's very limited interaction between them. One of the areas we've been working with Parity really late last year, in Q4 last year, was to add this type of flexibility or this type of functionality to Substrate, and that's now been added by the Parity team. collaborating with Polymath, and that all of that functionality is in the the public master branches of Substrate and Ink, which is the kind of Substrate DSL for writing smart contracts. So, I think this type of functionality, I think it's very interesting. I think it's obviously very important for our specific use case, but it feels like something which other projects building on Substrate will also be able to leverage in lots of new and exciting ways. Right, let me just take a quick look at. There's a few questions. Let me just run through those. I'll take a quick pause here to do that. So the first question, which has got 3 votes, is there a testnet available for Polymesh for us to take it for a spin? I mean, the answer is that right now we don't have a public testnet. Our roadmap, I have a slide at the end of our roadmap on. Our roadmap is to have a public testnet in Q2 this year, so that's fairly soon now. Having said that, if you want to take it for a spin, I mean, our code base is public. I have a link to the code base on the last slide, but I think if you Google Polymath Network or Polymesh and GitHub, you'll get to it. And the code base is open, so you can certainly pull the master or develop branch, compile it, and run a kind of private testnet if you want to take it for a spin. And there are instructions on the README on how to do that. And as I say, we're aiming to have a public testnet in Q2, so pretty soon. So that was one question. What are the requirements for becoming a permission validator? Can a Polymesh fan become one? So this is an area that we're still working through. As I say, the reason we're permissioning validators is to make sure that every validator is a publicly identifiable organization or a company that has a kind of great reputation, and that kind of adds to the security of the network. So I'd say we're still working through exactly what those criteria are. We're talking to a number of organizations that might kind of match that specification. So probably this is a case of stay posted, but I can say that the intention is really to have, let's say, public, well-known organizations which can be, let's say, publicly identified and have a public reputation. Let's keep going through the questions. So if you look at the current validators for Kusama, will they, after a possible KYC, also be able to validate? I guess this is probably somewhat similar to the previous question. So yeah, as I say, we're still working through what the criteria should be for a permission validator in Polymesh. So I'll leave that one. And it said, where would an industry-specific regulator requirement fit in? Runtime module versus smart extension. So this is an interesting question. It can get detailed quite quickly, but so at the runtime module level, we have compliance built in at the runtime module level, and that compliance that's built in is really compliance based around identity and claims. I'll talk about this a little bit more in the next slide, but everything in Polymesh is mediated by identities. Identities can collect claims, maybe a KYC claim or a accredited claim or a claim that you're operating in a particular jurisdiction. And you can build compliance rules that leverage those claims. And maybe you want to say, I only want to allow transfers of my asset to investors which have a UK jurisdiction and have a KYC claim from a particular KYC provider, and that type of thing. So you can have these kind of claim-based compliance rules. All of that happens at the runtime module level. Where smart extensions come in is where you need more like esoteric or kind of asset-specific logic. So, for example, it may be that in jurisdiction transfers assets issued in a particular way may have maybe some sort of volume restrictions on how many assets you can transfer in a particular, say, 24-hour period. So more esoteric logic would live at the smart extension level, where you would build that logic as a smart extension or as a smart contract, and then attach it to your asset, and your asset would then validate that logic every time a transfer was made. So it's a great question. Some compliance is at the runtime module level, claim-based compliance, and then more like asset-specific compliance is at the smart extension level. Then there's one more question, which is, will smart extensions be activated by a smart contract platform on Polymesh since there won't be runtime modules? I'm trying to see if I'm not sure I exactly follow that. I mean, so maybe if it's asking who can deploy smart extensions, the idea is that
Hey everyone, I believe we lost Adam, so let me work quickly to try to get him back in the room. 1 second.
hey,
Hey Adam, it looks like you're back.
Danny, you there?
Yes.
Hey, I dropped off, I guess.
Yeah, it might be best to keep your camera. It might be best to keep your camera off now, just for the bandwidth issue, and then share your screen.
Okay, let me just give me 1 minute. I'll just share my screen again.
Okay.
Apologies about that.
It was a quick recovery.
Okay. Let's make sure I'm sharing the right screen. See if I can make that full screen again. So hopefully that's working. And then you're suggesting I turn off my camera, which I will do.
And we can see the slides.
Yeah. Where's the option to turn off my camera? I'm sure it's somewhere obvious.
I can do it for you if you want.
Yeah, that works fine for me.
Okay, you're good to go.
Okay, great. So I was just answering, I think I answered the last question. So the last question is, what will the performance of Polymesh be? I would say, this is something we're still profiling and improving, so I don't have any exact metrics around the performance to share right now. Okay, let me flick to the next slide. Okay, so this slide is this slide shows the overall architecture of the system. So we've talked actually a lot about some of these pieces already. There's one area I wanted to touch on a little bit, which is the bottom kind of row, which is the open finance protocol. So one of the kind of really interesting, innovative, and areas in kind of huge explosion of interest in over the last probably 12 months, maybe a little bit more, is around these sort of DeFi protocols or open finance protocols. So some of the examples are listed at the bottom here, things like DEXs, lending protocols, and so on. We want Polymesh to be a platform that really kind of fosters this type of innovation, and I think it's also quite uniquely positioned on this side of things. So what does Polymesh bring to this space, which is kind of unique and novel? I think there's kind of two key things. The first is that because we have all this layer one functionality and smart extensions that help you create and manage regulated assets, it means that today's DeFi protocols mainly deal with, I would say, utility assets or things like Ether, these kind of native coins. And really one of the sort of holy grails of DeFi is to be able to expand that to also start including regulated assets, which one of the big problems with using things like Ether and BAT and these other kind of utility tokens as collateral is that the prices of these things tend to be highly correlated. When the price of Bitcoin drops, the price of Ether drops, and so on and so forth. And of course, they're not exactly correlated, but they are highly correlated. So if you can start bringing in regulated assets that really are very uncorrelated to crypto assets, that allows you to kind of change some of the characteristics of these DeFi protocols and gives a lot more kind of stability around use of collateral and these types of things. Also being able to borrow and lend regulated assets opens up a whole kind of range of different types of protocols, which are interesting both to, I guess, existing DeFi users as well as more traditional financial market innovators and investors. So that's kind of one area, is that Polymesh brings in these regulated assets, which have all the things we talked about in the previous slide. And then the other really important thing that Polymesh provides is it provides Sybil protection. So Sybil protection is this idea, let's say on Ethereum or on most, say, public networks like Bitcoin and Ethereum, it's very easy to spin up new addresses, new identities. You can kind of create a script that creates thousands of new Ethereum addresses very quickly. And it's very hard if you're building a DeFi protocol or an open finance protocol. It's very hard to sort of, tell whether you have one user masquerading as 1,000 addresses or 1,000 users, each with their own address, or somewhere in between. And this brings in lots of challenges around things like governance for these decentralized financial protocols. And also, is really what drives this idea that most of the current DeFi protocols are based around over collateralization. So because you don't have any kind of Sybil protection, you don't have a strong idea of identity. The way you protect yourself is you make sure that any lending or borrowing rather is fully collateralized or over collateralized, which works and kind of seems to be working pretty well right now. But probably in the longer term becomes a less attractive way of deploying capital. So what Polymesh allows is it kind of dramatically increases this design space for these DeFi or open finance protocols. And being able to use Sybil protection lets you build out these kind of interesting governance and signaling schemes around DeFi protocols, and maybe rather than just relying on over collateralization, allows you to rely on maybe some mixture of reputation and collateral to guarantee good behavior. So that is an area I think that's worth focusing on. I think DeFi or DeFi is a really interesting area. I think it's one area which really, when people talk about kind of killer apps for blockchains and so on, it's one area that really seems to have kind of taken off and provide genuine additional utility over what's possible with paper assets, let's say, or traditional assets. And that's something where we're really focused on making sure that Polymesh is this kind of great environment to foster these third-party innovative DeFi protocols that can kind of come into the platform, build their protocol using build their protocol on top of our platform, which can leverage all of our primitives and some other extensions. Okay, so I'll answer this one question just as we go. So there was a question that says, how's code protected from competitors? They can copy Polymath hard work and try to sell before Polymesh. I mean, certainly our code is open source. That is true. I think that probably the answer here is similar to the answer probably for many different blockchains. Ethereum also is open source, and many other blockchains that are open sourced. I think I'm trying to remember exactly what the phrase is. Something you can copy the code, but you can't copy the kind of network of participants. And Polymath has been in the industry for a good amount of time now. We have a great brand. We have a huge network of stakeholders and relationships and partnerships. I think if you go to the Polymesh website and look for partners somewhere in the top menu, you can see a list of all of our service providers, and we have a really vibrant, large list of service providers. So I think that's really a strategy. There is that they can obviously you can copy code, but what they can't copy is our traction, our adoption, and our network and relationships. The next question is, are you afraid that your permission chain infrastructure and KYC requirements will hinder adoption from crypto DeFi investors? I mean, I would say this is definitely something we're really focused on. So we have, Polymath has a great product team, has a truly kind of world-class product team. And as a company, we're focused on solving real problems, right? So we're not interested in just building tech for the sake of for the sake of tech, even if that technology is really cool. Our approach is always to start from a problem and then figure out what technology is most appropriate to solve that. So we are, we're a very kind of product-focused company. We're focused on solving real problems. And one of the big issues in the crypto space at the moment is UX friction, user friction. So we're highly aware of that. We've put a lot of thought, effort, and design into making sure we minimize those kind of friction points for investors, both traditional investors and, I guess you could say, kind of crypto or DeFi type investors. So it's something we think deeply about, and it's something that we will be, getting Q2 this year. We'll be releasing a whole bunch of tooling around the chain, and hopefully, when people start playing that tooling, they'll, the kind of effort we put into reducing that friction will be apparent. So all I can say, I guess, is that we are thinking a lot about this, and aware that this is one of the trade-offs around this approach. Okay, so how are we doing for time? We're at 40 minutes. Okay, I'm going to flip to the next slide. Okay, so I'm going to talk a little bit about identity. So identity is one of the core design principles of Polymesh. I'm going to talk about this fairly briefly because I think we're 40 minutes in. But the idea is that one of the things that differentiates Polymesh from other blockchains is that so typically in a blockchain, when you think like Ethereum or Kusama or Polkadot, every transaction is associated with a public key, and that's the kind of linkage you have between something off-chain and something on-chain. In Polymesh, every transaction is associated with an identity. So an identity is a collection of claims. So you see a couple of claims on the slide. So an identity is really just a collection of claims that other people have made about your identity. So that might include, a KYC provider attesting to your jurisdiction, or somebody else attesting to whether or not you're an accredited or sophisticated investor, and so on. And every single transaction in Polymesh is associated with some identity. So what this gives you is it gives you a kind of very clear sort of network topology and provenance for transactions, because everything that happens on chain is associated with these identities, and that's one really kind of key difference between Polymesh and some other blockchains that are out there. In terms of our approach to identity, there are some sort of W3C standards around decentralized or self-sovereign identity, decentralized identifiers, and so on, and we try to cleave to those standards where it makes sense. Our implementation of identity is very much focused on regulated assets and compliance and regulated securities and capital markets. But where it makes sense, we've used we've followed standards where it makes sense. I think that kind of covers that slide. Let me just click to the next slide. So yeah, so one of the other aspects of identity is key management. So every transaction has to go through one of these identities, but you still have to kind of be able to authenticate access to an identity. And every user needs a way to kind of control or manage access and permissions around their identity. So the way we've approached this is that every identity has a master key. So you can think of this maybe as being your hardware wallet, or maybe a multi-sig where the signatories of that multi-sig are members of your organization, and that's a kind of like an admin key. It has full control over the identity. But you can also create one or more signing keys, where a signing key is provides a way to authenticate as that identity, but to have more constrained roles or permissions. So, for example, it may be that you want to hand out a signing key to one of your employees, but you want to limit that person to only be able to deal with a certain asset or assets, or maybe only be able to issue claims against other identities and not be able to transfer your assets and so on. So you can have this kind of granular permissions and role-based permissions at the signing key level, which allows, which means that every owner of an identity can sort of manage their security requirements and needs themselves, and have this kind of fine-grained control, and also delegate activities to other individuals. So I think in the slide, if I flip back to the slide, so in the slide we're showing. So you have this identity of the Apple issuer, which has a bunch of signing keys. Some of the signing keys might be multi-sig, some of them might be just external addresses. In this example, one of the signing keys is actually another identity, which is a transfer agent identity. So it kind of gives you this very flexible way to model different types of organizations and different ways that organizations interact and the kind of topologies of these different types of organizations. The other thing that should be mentioned is that all of your assets, all of your security tokens are held at or are associated with a particular identity, and they may be organized into portfolios under that identity, but ultimately, all of these kind of security assets roll up to a particular identity. So for asset issuers, you always have this kind of very clear idea around compliance and so on. Okay. Go, so I have a couple more slides left. So in terms of roadmap, I mean, it's pretty clear here. I think I mentioned before that we released our white paper a few weeks ago, which you can find on our website, which is polymath.network. And then we will be releasing a public testnet in Q2 as the next kind of major phase. And it's likely, and we're still kind of planning out the details, but we may see some of these things being our roadmap is to have a public testnet in Q2 for everyone to be able to play around with. I think, as mentioned, so our code base is public, it's open source. So if there are any developers on the call, I highly recommend going to the code base, having a poke around. The main code base for the core blockchain is all in Rust, which is what Substrate itself is written in. And you can see you'll be able to see our activity, our pull requests, and so on going through on that network. And I think, as I mentioned, if you're super interested, you can pull the code, build it on a node, and interact with that node. And there's instructions on how to do that on the README of the GitHub. One thing I want to mention is that we are hiring. So in particular, if there are any full stack developers on the call or any DevOps experts on the call, then we're hiring. We're always interested in hearing from developers or developer community. So our email address is just there. Or you can reach out to me directly. I'm adam@polymath.network. So you can reach out to me directly or to our recruiting email address. But we'd love to hear from anyone out there who's interested in security tokens or in building blockchains. That's it on the slide side. And I see there's one more question. So let me step with it. So it says, do you expect companies utilizing third-party services for token issuance and trading? And what are your thoughts on securing the master key? So let me do the second bit first. So securing master keys, clearly a complicated topic. I mean, one of the advantages of working with Substrate is that there are certain types of integration which are generally useful. So things like hardware wallet integrations. So we were just talking to one of the companies that received a Web3 grant to build a hardware wallet integration for Kusama, and then maybe Polkadot as well. Now, of course, there might be some customization required, particularly for Polymath, or Polymesh, but a lot of the basic work is already kind of dealt with at the Substrate layer. So certainly, hardware wallets, I guess, is the often kind of quoted way of having a secure master key, and there's always ways to have multiple hardware wallets if you want some redundancy and so on. So Polymesh also has multi-sigs, where the keys of that multi-sig can either be other identities or hardware wallets, or in fact even other multi-sigs for that matter. So if you're an organization, it may be that a multi-sig wallet is the most appropriate setup for you, where you maybe require 2 or 3 signatories to authorize a transaction. And then there will be other I guess, probably more flexible key management software, things like Chrome plugins and that type of wallet software, which may be appropriate, maybe not for managing a master key, but for managing signing keys that have limited permissions. The first part of the question, which is, do you expect companies utilizing third-party services for token issuance and trading? So if I interpreted this correctly, I mean, so as I say, definitely Polymath's approach is to build functionality not just in-house, but through partnerships and integrations. So whether that's integrations with exchanges or custodians, or transfer agents, or KYC providers, we're not planning on building. That's all so Polymath is not going to be building all of that stuff, right? That type of functionality we will achieve through integrations with our existing partners, which we have many from our kind of Ethereum protocol, and obviously new partners that maybe make sense on Polymesh specifically. So absolutely, we expect companies to be third parties or companies to be interacting with the blockchain and managing token issuance and trading on behalf of other people. And then there's one new question, which is it possible to do reporting to regulators through Polymesh and taxes? So it's a great question. I mean, I think one of the, we've had lots of conversations with different regulators, and of course, regulators are not like a unified body, but every jurisdiction, every region has its own regulator. So there's probably no single answer. When I think about what the advantage is to regulators of putting securities on a public blockchain, I think there's a couple of key advantages. One is that you can do your compliance in real time. So traditionally, compliance would be a after the fact activity where maybe every 6 months a regulator comes in and audits your books and records, make sure that you've been reporting things correctly and you've been enforcing compliance correctly. With protocols or blockchains like Polymesh, all of that compliance can be done in real time as transfers are happening. So you don't have to kind of come and do a retrospective audit. You just have to audit that an asset has the correct compliance rules attached to it. And then you have this kind of guarantee that those compliance rules are respected as transfers of that asset are happening. So that's one big advantage to regulators. And the other is that you have this kind of transparency, certainly for non-confidential assets. You have a single source of truth, which is the blockchain, and let's say the ledger of the blockchain. And that can be used for all sorts of things like reporting, tax reporting, and so on. With confidential assets, it becomes a little bit more complex. You want that data to be available to issuers so they can do their reporting, but not available to the general public. So it becomes a little bit more nuanced and complex. And I guess tax is in a similar case. I don't think there's any plans to build tax software in-house at Polymath, but absolutely, having let's say a third-party organization building, or let's say integrating with Polymesh, that you can pull in your raw data from the Polymesh ledger to calculate your taxes and do your tax returns would seem to make a ton of sense. Okay, I think that is all of the questions I see in the Q&A box. I'm having a quick look through the comments, but I think that's all answered as well. Back over to you, Dan.
Yeah. If anyone has any more questions, speak up in the chat or the ask a question section. If not, we can send a follow-up email with some of these links and email addresses that Adam mentioned in the presentation here, along with the link to the video. But I just want to say thanks, Adam, for the great, insightful presentation, and thanks for coming on and presenting to us.
No, great. Thank you very much for having me, and it's some great questions. So that's always great to hear.
All right. Thanks, everybody. Have a good day.
Thank you.